the whole event. Make sure that you're staying on the Zoom call. Also, make sure your mics are turned off. And then I'll put my email in the chat. And at the end of the event, send me your ID number and your name. And if you're with anyone else, send me their ID number as well. Yeah, I think that's it.
Okay, thank you, Skylar. This afternoon, I keep wanting to say this evening, and it's not yet evening time. But this afternoon, we welcome Professor Lindsay Fox to Research Bites. Professor Fox is going to speak to us a little bit about her undergraduate research experience, as well as the work that she's doing right now, specifically some of the research that she's doing with mathematical modeling to study the transmission of infectious diseases, which of course is always an interesting chat, specifically during a pandemic. But we welcome Professor Fox. And what we'll do is we'll let her kind of give you a little overview of her experience and kind of give a frame. And then we'll open it up to questions. Those questions, because we do have a fairly large group, which is awesome. Thank you guys. We will be asking that you just pop your message or your question in the chat box. And if you would like to read your question, then you can go ahead and read it, but I'll just ask, I'll call on you in that way. If you are feeling a little apprehensive and you're not quite sure if you want to just ask a question, you can private message me in the chat feature, and I will amplify your question to Professor Fox. And then of course we'll kind of move through the Q&A. We are recording this, so we will have that on our website too. And so we'll go ahead and turn it over to you, Professor Fox.
Hi, everyone. I'm Professor Fox. Like Kat or Dr. Robinson has explained, I'm in the math department here. I've been here for about a year and a half. I came right out of grad school. So when I was in undergraduate, I wanted to go to medical school to become a medical doctor. And it took me all 4 years of college to finally decide that that was not the path for me. And so I ended up going to graduate school instead for mathematics, but I still very much loved the biology, anatomy, medicine type of things, and wanted that to remain a part of what I studied. But I discovered that mathematics is not always about creating new math. There's a whole part of mathematics that's about using it as a tool to study other things. And so that's what I do. I use math to study biological type questions. And in particular, I'm very interested in studying how diseases are transmitted between different people. And so a current projects I have going on, one is looking at the bacteria C. difficile getting spread between patients in hospitals. And then I have a project with undergraduates here at Eckerd who are not math majors. They are both biology majors. And we're studying COVID being transmitted on campus. And the goal of that project is we want to estimate the number of quarantine beds that Eckerd needs throughout the pandemic. So I guess open it up to questions.
Yeah. So thank you so much for the frame and for the exploration. So we'll go ahead and open up for questions. If you can go ahead and put your question in the chat box, and then I'll either call on you, or you can go ahead and just type it in there. But I'm going to start off with a question because I'm always curious about how you mentioned kind of shifting from pre-med to math. How did you make that decision? Like, what was the spark that said, yep, math is my thing?
So I had always heard that getting into medical school is really difficult and you want to do everything that you can to stand out. And so I was always good at math in high school and I thought it was fun. So I decided right when I got to college that I was going to be a math major. to stand out on medical school applications. I knew I was going to have to take the science classes anyway. And just kind of throughout my classes, I just discovered that it's more than just fun. It's really what I wanted to do. Really, it took me a long time to realize that. It took kind of a traumatic moment for me to realize that medical school was not for me at all. I took a class that was about kind of what you would be doing on a day-to-day basis as a doctor. And we practiced patient interviews. And my patient interview was to tell this patient that they had just been diagnosed with breast cancer. And I was so nervous, and I ended up just laughing through it all. And it was humiliating, and realized I could not do this, that I'm more interested in learning about how the body works, not so much treating people with ailments.
That had to be a traumatic
It
experience.
was traumatic.
Sean Murphy, you've posted a question. Would you like to come off mute and ask Professor Fox your question?
Sure, Professor Fox. Just curious about what sort of math backgrounds needed for the type of research that you're doing now, and I'll just amend that with maybe like what sort of technology tools you use.
Mm-hmm. Yeah, so the minimum class that I require is just Calculus 1. Really, the main tool that I use in my research is the derivative. So if you've had calculus, you know what that is, but it's a tool that describes how things change over time, which is the main piece of disease modeling. We want to know, how does the disease spread over time throughout a population of people? And so that's kind of the minimum level of math knowledge that's needed. And then in terms of kind of the different like actual tools that I use, I do a little bit of computer coding, but not like you would as a computer scientist, but more of the types of equations we're working with are fairly complex, and we don't want to solve them by hand. So we have the computer solve them for us and plot some nice graphs and that kind of thing. So no computer science background is necessary, just a little bit of Calc 1 and a curiosity about how to use it.
So I have a private message question, and I think this might speak to the individuals who might have math anxiety. Do you have to be good at math to do the kind of research you're doing? So I'm not quite sure how to frame that, but I feel like that might be about anxiety, about how does one get to do this kind of research, and what level of math do you have to have?
Yeah. So again, the minimum class is Calc 1, but I don't require, my research students to be math pros. I don't even consider myself, in terms of some of the more pure mathematical areas, an expert in some of those skills. What I really like about kind of my area of research is that it's very accessible. The types of problems we're trying to solve, the questions we're trying to answer, the general public understands what we're doing, what we're trying to accomplish. And so if keeping that in mind, the math is almost secondary, because you're thinking about the math as just, these are tools to accomplish this goal. So going along, as we need to do something else, we pull in this tool and we talk about, what it means, how we use it, that kind of thing. So I think that's the best way to answer that question.
I've got to thank you from the student. So, I mean, that's a good one. I get a sense that sometimes people are like, do I have to be, a very proficient mathematician to do this kind of work, or kind of a theoretical mathematician? And I'm glad that you kind of put that in there. I have another question, also direct message. What types of activities do your research students encounter daily, and what type of tasks do they do?
So usually at the beginning of a project, it's a lot of reading. because you want to learn a lot about how whatever disease you're looking at, you want to learn a lot about how it works. So what are the symptoms of the disease? How is it treated? How is it transmitted from person to person? So yeah, that's usually a large chunk of the project, to be honest, is a lot of reading. In particular, a lot of times in the reading, we're looking for specific numbers too. So for instance, if a disease has an incubation period, so the incubation period is the time period in which you have contracted the disease, but you're not contagious yet. And so looking in the literature for, if there's an incubation period, how long is that? Or how long is the recovery period? So things like that. Other kind of assignments my students work on is a little bit of the code. So we go through, we start from scratch, because again, I don't require my research students to have any background in coding. And so we start at the very beginning and just build up a little bit of foundation there. And then we take some kind of basic disease model files and we learn how to augment them to the particular disease that we're working with. So the students do that. The students also work on, so one thing that's nice about math, or well, not so nice about math, is that oftentimes in presentations and things, you don't have a lot of pictures. It's a lot of equations. But with our disease modeling, you want to have nice like schematics or flow charts to kind of illustrate how your model works, how the disease is transmitted between different groups of people. And so they spend a lot of time actually just creating nice diagrams as well to go in their presentations. And so kind of the last thing that they spend time on is a lot of times we're just sitting around kind of talking about, so these are different aspects of the virus. How should we implement those in the model? Because in reality, or in disease modeling, what happens is that you have to make certain assumptions about how the virus works. And a lot of times you can't fully capture reality in your model because it's too complex. What's happening in the real world is too complex for any set of equations to capture. So we have to make some assumptions to simplify it somewhat so that it's actually something we can work with. So a lot of times we are just sitting around chatting about, what assumptions can we make? What assumptions should we not make? How does, the different pieces of how the virus work fit into how we're trying to model it.
Excellent. I have another question that came in direct message. Have you done studies on disease transmission in animals or plants? And how is this, or would it be different?
So you can certainly do disease modeling for a disease of any kind. So rabies is a really common one. There's a lot of models out there for rabies. You could definitely do disease modeling for diseases in plants. I know a little less about the plants because I'm assuming the way that viruses are transmitted between plants would be a little bit different than how they're transmitted from person to person, because plants don't, cough and things like that. Yeah, so you can apply kind of the foundations of what a disease model is to just about anything. And as an example, a new project that I just jumped on board with some of my research colleagues from graduate school, we're actually looking at how different levels of government and their different, I guess, kind of protocols on how to handle the virus. So like different strengths of mask mandates and that kind of thing, how they actually influence the transmission of the virus. So, maybe you have two states next to each other that have at the state level different strengths of mandates, but then you have the federal mandates on top of that. And so which state is doing better at controlling the disease? So there's all sorts of questions and things that you can look at with disease modeling.
Well, thanks. I think Anna, you had a question. Do you want to come off mute and ask it?
Yeah, and you kind of started touching base on it, but I was just curious about other examples, different diseases that you've worked on in addition to COVID.
Yeah, so I actually haven't worked on too many because a lot of these projects take a long time. And one reason for that is because in the math bio world, you tend to have a lot of colleagues that work together on a project. Because it's nice to have like a biologist or an epidemiologist on board who knows a little bit more about the particular bacteria or virus you're working with. And so the projects tend to take a lot longer than if you were just working on the project individually. And so I've only worked or have constructed models for C. difficile, which is the bacteria in the hospitals, and COVID. I did have a student last year. We started a project about herpes in turtles, but she unfortunately did not come back to Eckerd and had to change schools. So we did not get to finish that project. But yeah, that's, I guess, the only other one that I've